of sines, even if you maybe didn't remember what law of sines was whenever I mentioned that to you yesterday. So that first slide that you have there has the law of sines on it, which is sine of capital A over lowercase a, sine of capital B over lowercase b, sine of capital C over lowercase c. So the way that this works in your triangle, the capital letters are your vertices that represent your angles. So in this particular triangle, I've got capital A, capital B, capital C. That is just standard mathematics notation to use a capital letter to refer to those. And then the side across from that angle is labeled with the lowercase of that same letter. So sometimes you will have these given to you, and they won't give you a picture of the triangle. They'll just tell you capital A is 20 degrees, lowercase a is 7. So they'll just give you that information. So assume that the lowercase letter is across from the angle that goes with it. All right, so the big thing we have to watch out for, the thing that law of sines would probably be easier than regular trig if it were not for the ambiguous case. You must be careful. If you are given ASS, this is an angle that is not between the two sides. Two different triangles may be possible. So, now, Miss Hendrick the other day, she was talking about side-side angle. I deliberately put it in this order because when you see this, you know that that's not something that you should have, right? You should not be writing that down on your paper. In Math 2, you do congruent triangles. And so with congruent triangles, there were a lot of different theorems that you could use to prove that triangles were congruent. So you could do side, side, side. There was a side, angle, side. There was hypotenuse, leg, angle, angle, side. You had several different ones that you can use to prove that two triangles are congruent. But one that you could not use was angle, side, side, because angle, side, side, it's possible that there's two triangles that have those measurements. And so what that means is whenever you're looking at a triangle, whatever that triangle may look like, you have an angle and then you've got two sides, but those sides do not include that angle. So it could be like this. It also could be something like this. Basically, it's the two sides do not have the angle in between them. It does not mean we cannot use law of sines for these problems, but it does mean we have to watch out for what we call the ambiguous case. So, at the beginning of every problem, we're going to decide if we have angle side side. And if we have angle side side, we're going to have to test for that ambiguous case, and I'll show you how to do that. Here's our first problem that we're going to do. I have two angles, and I have one side. So I've got angle, angle, side. That side is not between the two angles. When it's between the two angles, we'd call it angle, side, angle. This is angle, angle, side. But it really doesn't matter which one it is because we do not have angle, side, side here, right? If we have angle, side, side, then we need to watch for ambiguous case. We don't have to check for the ambiguous case here because we have angle, angle, side. It's only ASS that is going to cause us to check for that ambiguous case. So the way that this works is you just need to take an angle. So I've got sine of, I'm going to pick 37 to use first. It really doesn't matter though which one you pick first. Sine of 37 equals over the side across from it, which is 3, equals sine of 68 over the side across from it, which is B. Yes. In this case, we're looking for the side, the little b that's missing. If we needed to find the missing angle, we could, though, it would be very simple because we would just have to take 180 and subtract 37 and 68 for that. So we wouldn't actually have to use any trig for that. And sometimes we have to do that before we actually begin the problem, but not in this case. So if we want to solve this, we could cross multiply. We'll get b sine 37 equals 3 sine 68. And then remember, sine of 37 is just a number. You can type it into your calculator. It's going to give you a decimal. So I can just divide by sine of 37 to get that b all by itself. So let's get the other calculator. Alright, so all we have to do to type this in is 3 sine 68. I'm going to hit enter before I divide, since I didn't put parentheses around that. Sine 37. This may not be right. Let's see. I'm not sure if I'm in degree mode or not. I am. Okay, so it should be correct. So we got 4.622. Would be our answer. So the length of this side right here would be 4.622.
For the rest of this time, we are ready for group 3 for sports physicals. Group 3 can report to the media center at this time.
Really? Of course, school physicals are always very thorough. Yeah, they're always like bend over, touch your toes. Maybe take your blood pressure and send you on. Okay. Alright, questions here? Alright, now the good thing about law of sines is it works for every single triangle. You don't have to have a right angle. Notice we don't have a right angle in this triangle, so it works for any triangle, including right triangles. So some students give up on sine, cosine, and tangent and just start using law of sines and cosines on triangles because it does actually work if you have a right triangle. Now there will be, sometimes some problems may sort of require you to use it, like ACT sort of problems like that. Those first ones we were doing yesterday with the if sine is this, find cosine, that you would not be able to use law of sines for. But you can use this for right triangles as well, if you so choose. Alright, so for this one, we have triangle PQR. P is 28, Q is 22. Measure of angle P is 120. We need to find R. So remember, capital letters are our angles. Lowercase letters are the sides across from those angles. So I usually draw me just a triangle and label the vertices. But keep in mind here that it's not to scale, because I just randomly put those on there. So it's not to scale. It's just to help us set things up. So you don't want to think of your picture as it's drawn to scale. So lowercase p would be across from angle P. It would be 28 right here. Q, we'd have 22. You can see here's a great example of why that's not to scale. 22 looks longer than 28. But it really doesn't matter. We're just helping us set it up. And then angle P is 120 degrees. That definitely does not look like 120 degrees. If you want, you can go back and try to draw it more to scale if you want. But we mostly just need to set this up. But first, before we look at anything else, I need to see if I have angle side side. So there's definitely a chance of it because I got two sides in an angle. Is my angle between the two sides? It is not. So I have angle side side. Watch out. Okay, so I will show you on this one how to check for the ambiguous case. This is the only time you're allowed to write ASS on your paper without getting in trouble. There, just make sure you are able to explain that to Mr. Hull whenever he walks in, what ASS stands for in that particular case. For this problem, we need to find measure of angle R. But do we know the length of the side across from R? We do not. So if I set it up with angle R, then I would have, don't necessarily write this down because it's not going to be right, I would have sine of 120 over 28 equals sine capital R over lowercase r. Can I solve that equation when it's got those two variables there? No. So, what do I need to do instead? Is there an angle I can find that is missing? I could find Q, right? Because I could do sine Q over 22. Once I find Q, all I have to do to find R is do 180 minus 120 minus whatever I get for Q, and that's going to give me that side R, so, or angle R. So it'll be really easy to find R once I've found Q. So we're going to find Q first, and then we'll look for R. So we've got it set up here. Do copy this down now. This will be correct. And to solve, we just need to cross multiply. We've got 28 sine Q equals 22 times sine 120. And we are trying to get that Q by itself right there. So first we'll have to get rid of that 28 by dividing. So I'll get sine of Q equals, I'm going to go ahead and type that into the calculator, 22 sine 120 divided by 28, and we'll get 0.6804. Keep that number in your calculator. Alright, so remind me, how do I get rid of sine? Inverse sine. So I'm going to inverse sine of both sides. You guys know about the answer button on the calculator so that you don't have to type that number back in. If you do inverse sine, and then if you do second and the negative key right there, it's going to say answer, which means it's going to take the answer from the line before. That way you don't have to copy and paste it. Plus it keeps more decimals, so it'll be even more accurate. So we're going to get 42.879 if we round to 3 places there. Okay, so right here is where we have to check for the ambiguous case. So you probably want to write this down maybe in a with star or box or something. For angle side triangles, once you find the first angle you must check for the ambiguous case. And ambiguous, we know the meaning of ambiguous outside of math just means unclear. And it's unclear here because it could be more than one answer. So to check, we're going to do 180 minus the angle and see if that also works in the original triangle. So whenever we do more with unit circle, we'll talk about why you do 180 minus the angle. But right now, just take my word for it that it is going to be 180 minus that angle. So if we take 180 and subtract that angle that we just got, so for checking, we're going to have Q. I'm going to put equals with a question mark over it right now because I'm not sure if it does or not. That's not official mathematical notation there, but to help us remember, we did 180 minus the 42.879, which gives us 137.121. Okay, so sine of Q could equal this value for 42.879 and also for 137.121. However, if I go back to my original triangle, I already know for sure that Q has to be correct. The first answer it's going to give you is going to be correct. But the second one, when we do 180 minus that number, it might work. In this case, if I plug it in over here, if I do 137.121, is that possible? Okay, it is not. Why do we know it's impossible? It can't be above 180. And if you have two obtuse angles in a triangle, you're not going to have a triangle. You're going to have something that looks like this and doesn't connect, right? So this is impossible for this triangle. So we would say this is impossible. Not ambiguous case. Okay, you wouldn't necessarily have to write all that stuff down. I'm just trying to make sure you've got it for your notes. So angle Q is 42.879, and it is only 42.879. There's only one answer. But the question asks us for R. So if we want to know R, measure of angle R is going to be 180 minus 120 minus 42.879. There, I'm just taking 180, subtracting the 120, and subtracting what we got for the Q. So we'll have here 17.121. So measure of angle R is going to be 17.121. And that would be our answer for this problem. I should put a degree mark there. Okay. Alright, so let's look at this problem. This one asks us to solve the triangle. I did redo the worksheet for the what I usually give you, I do not like solving triangles, because to solve a triangle means that you must find the length of all sides and the measures of all angles. So it means it's really like 3 problems in one that you have to do. And if you get an ambiguous case problem, on top of it being law of sines, then it's going to be like 6 problems in one. They ordered us the program, the CUDA worksheets that I usually give you. Usually I just use the free ones, but they ordered us the program so I can actually like make my own worksheets now. So I took a lot of the solve the triangle problems off. There's still a few because sometimes you might need to know how to do that, but I took a lot of them off just because it takes forever to do whenever you have to do this. So, but we do need to know how to do at least one of these. So this problem's going to be a little long because we got to find all of the pieces. Plus, whenever I look at this, do I have angle side side? Yes. So this is angle side side. We got to watch out for that ambiguous case. All right. So, but as far as first step, doesn't change anything. We're just going to set it up. So, Braden, what would I do to set this one up for that first step? Sine C, good, over 26. And we're going to have to find 26, sine angle C first, because that's the only one that we have the side across from. Okay, so from here, we're just going to cross multiply 25 sine C equals 26 sine 70. I'll divide both sides by 25. And we got 26 sine 70 divided by 25. So I get 0.97728. Keep that number in your calculator. And then, remind me, Jackson, what is it I got to do to get rid of that sign? Inverse sine. So I'm going to inverse sine that answer. And I get C equals 77.763 degrees. Now, I'm going to do something here that can be helpful. I'm going to hit the store button. So the store button is right above your own button, STO, and it's got that little arrow. And I'm going to store this as the letter C. Okay. So what that does is now anytime that I want to type that big long number, I can just type C instead, and it's got that value stored as my C, because it might be helpful in finding the sides that we need here. So I'm going to go ahead and store that as my C. So I need to check for ambiguous case. To do that, I'm going to take 180 degrees and subtract the 77.763 degrees. This is C, possibly. I'm going to put a question mark there. So if I do 180, and since I've stored it, I mean, right now I could just do second answer, but I could also, since it's stored, do 180 minus C, and it'll subtract for me there. So I get 102.237. So you don't have to test C. We know C is correct. They're the first C that we got, right? What I want to do is I want to put the second number that I got for C up here and see if it would work. So I've got 102.237 degrees. Would that work? Is that possible for this triangle? If I add these two together, what do I get? 172 point something. So that means B would be a teeny tiny little angle, but it is possible. Now, always we have to assume pictures are not drawn to scale. So certainly if we knew for sure this picture was drawn to scale, this is unlikely because that's not an obtuse angle, right? And B doesn't look like a teeny tiny sliver of an angle. But in general, for problems, we are required to assume that it is not drawn to scale. Pretty much every test you ever take will tell you it's not drawn to scale. Although they will usually be drawn to scale for the most part, except for ambiguous case scenarios that may not be. So what this means is since that will work, since that is less than 180 degrees when I add those angles together, that means we have ambiguous case. So that means that measure of angle C could be 77.763, but it could also be 102.237 degrees. So this is like the worst possible type of problem because they asked you to solve the entire triangle. So you got to find all the sides and all the angles, but there's two possibilities for C. So what you'll do whenever this happens is you got to pretend that C equals 77.763, and you'll solve all of those possibilities. Then you have to go over here and pretend that you know that C is 102, and then resolve it over here. So let's look at, we're going to ignore this for a moment. We're going to pretend that C is 77.763. So to find B, we would just do 180 minus 70 minus that value for our C. Uh-oh, what did I do? Oh, I hit second. What's that? Alpha. Okay, so our angle B here would be 32.237 degrees. For precision, I would suggest storing this as B. So now if you type B, it's going to be that number, so you don't have to round it off. If you round it off, you'll be pretty close. It could cause you to be far enough off that it would make a difference depending on what type of numbers that you're working on and what level of precision that you need. So it's best just to go ahead and store it, and then you don't have to worry about not being precise. Don't round the answers till you get down to the end. All right, so now we have all of the angles. So in this case, for this first scenario, we got 77.763 here, and then we've got 32.237 here. So the only thing we would be missing is side B over here. And so what we'll have to do for this one is we're going to have to set up the law of sines again. I typically use 70 and 25 when I set this up because those numbers are not decimals and are just easier to work with. Plus I know that I don't have any rounding errors or anything with those numbers because they're just original from the problem. You could, however, use 77.763 and 26. And B is what I'm trying to find, so I'm going to do sine of 32.237 over B. And we will cross multiply. We will divide by sine 70. Alright, so what we're going to get here is we'll have 25 sine of, I'm going to use B because I stored that number, divided by sine 70. And so that is going to give me 14.191. The rounded value, let's see how far off it puts us. It would not be close enough to it would not make a difference in your like 3 decimal places in this case, but you can see here we got 1912, and right here we got 1914. So using that rounded value does throw it off a little bit, so it's better to keep that stored in your calculator. A lot of times it might not be enough to make a difference, but sometimes it might be. All right, so these 3 right here are one set of answers. So these 3 go together here. That is one possibility for this triangle. But it is not the only possibility because this is an ambiguous case problem. So let's go back now and let's imagine that instead of 77.763, we've got, we've got 102.237 degrees. All right, so for this, to find B, we're just going to have to do 180 minus 70 minus the 102. I am going to do this as well. I'm going to do 180 minus C. That gives me the 102. That gives me the long decimal for that. And I'm going to now store that one as my C. It replaces the number that was already there. And so I can do 180 minus 70 minus that C value, the 102. And I'm going to get 7.763. For our B. And I'm going to store this as my B. It will replace the B that is currently there. Now, if you think about what you're going to do here, I'm going to write it all out, but I'm going to show you how you don't have to. Sine of 70 over 25 is going to equal sine of 7.763 over B. So B sine 70 is going to equal 25 sine 7.763. And then we'll divide by that sine 70. But the only thing you changed was the angle values, right? So the way you solved it over here, the only thing that really changed was this angle right here turned into this angle right here. So you could just go back now and do 25 sine B divided by sine 70 without setting all that up if you want to save yourself a little bit of time. And so we get 3.594 whenever we do that. So B would equal 3.594. So that would be our third. So our other set of answers are these 3 right here. Now, you won't see this happen on many problems where you have to do this ambiguous case and solve the triangle, and it takes forever to do. But it might show up once. Questions on that? You may ask, what good is this in real life? This could happen very easily in real life. If you're whatever you are measuring and needing to find missing angles. If this happens in real life, what you need to do is go back and take another measurement, or it might be, like, you might know that the triangle looks like this, and that it's impossible for C to be a obtuse angle. So you would know that even though it's theoretically possible, it's not what's happening in this case. So that would be what you would do there. So, questions? Those are all the answers. Yes, you got basically 2 sets of 3 answers there. So these are super fun. Everybody's excited about seeing some of those. Yes. You don't. So, like, if I give you one of these on a quiz or a test, then you need to give me both sets of answers there. So you would give me all of the possible answers. In real life, you would need to go and make another measurement, take another measurement there. So, like, if that were the case, we would need to measure one of these angles and see what it actually was, if that was possible, so that we could know which one is actually correct for our triangle that we're looking at. But as far as quizzes and tests go, you give both answers because they are both possible answers, but we don't know which one would be the exact answer without having more information. Okay? Am I going to do that one? Let's skip over here to this one. Alright, we're going to skip number 4. This is another solve. It'll take us another while, and I'd rather you guys do some on your own than us do this forever. Alright, so we're going to do one application problem just to sort of introduce you to what you're doing here. And so, I don't know if you guys did this any in Math 2 or not, especially since you probably had a messed up Math 2. A few of you may have said something about doing it with Miss Ball, because sometimes she'll do a little bit of trig if she's got extra time in 8th grade. But have you guys ever made clinometers and went around the school and measured stuff? It had like a little straw and a weight. I'm sorry that you missed out on it in Math 2. I don't know if Mr. Brown usually does it anyway, but I usually have everybody make, when I used to teach Math 2, I haven't taught it in several years, I used to have everybody make little clinometers, and we'd go around the school and we'd like measure how tall the building was, and we'd use trig to measure all kinds of stuff. So this is roughly based on our experiments, except for these aren't actually their numbers because I forgot, I didn't write them down, so I made these up and it might be inaccurate. But this is talking about that chimney back here in between where you go from the band down to band hall down to the gym. There's a big giant chimney there, and the chimney is one of probably the most interesting things to figure out how tall it is on the campus because it's very tall. But the problem with it is that if you're down there at the chimney, we're going to pretend that ground is level, but it's not exactly level. The chimney is right here. With some smoke coming out of it there. And it would be really easy to do, except there is a fence, chain link fence, around the bottom of that chimney. So unless you're like one set of students that I had one time that went and found Miss Brown and got her to unlock the fence so that you could just measure all the way to the bottom of the chimney. The problem is we can't really make a right triangle like we would like to with this because you can't measure this all the way to the bottom of the chimney because of the fence there. So what we would have to do if we were going to measure this is we would stand somewhere and look up at the chimney and get an angle of elevation. So Aspen and Gillian do this, and the angle of elevation to the top of the chimney is 56 degrees. Then they step back 2 meters, and they take a second angle of elevation. And that second angle of elevation is 54 degrees. So what we want to find is we want to find the height of the chimney. Over here, I'm going to call it H. That's what we want to find, right? And we know we've got like a right triangle here. This is a right triangle. But if we look at this little right triangle that we've got here, we don't have the length of any of the sides. All we have is that angle right there is 56. So we can't use that right triangle. But what we can do is we do have this skinny triangle here. And for it, we have an angle and a side, and I could find another angle. I don't have this angle, but I could find it pretty easily. What could I do to find that angle right there? 180 minus 56, because these two angles make a line. So if I do 180 minus 56, that is going to give me 144. No. 124. Yes, that's better. So that's 124 degrees. Right there. So I've got two angles and a side, so I could find any of the sides that I need to of that triangle. So really, you can look at this inside side right here, or you could find this outside side right here. It does not matter which one that you find. I think I'm going to go with this inside measurement here. It really doesn't matter which one you use there, because you can either look at this smaller triangle on the inside, or you can look at this bigger triangle here as a right triangle. It doesn't really matter which one you find, this side or this side right here. So this X is across from 54. The only other side I know is 2. It's across from this super skinny angle right over here. It doesn't even hardly look like it's across from it because it's so skinny, but it is across from this side right here. So if I do 180 minus 54 minus 124, it is going to give me 2 degrees. And so right here, this angle is going to be 2 degrees. So for law of sines, I'm going to set up sine of 2 degrees divided by 2 equals sine of, since I'm finding this side right here, I want to look at 54. So sine of 54 over x. And so we will cross multiply x sine 2. Oh, I'm forgetting something. Do I need to worry about angle side here? I do not. I had 2 angles in my triangle, so I don't have to worry about it. So 2 sine 54 divided by sine of 2 is going to give us 46.363. You can store that if you want. I would just use the answer key. If you do store it, I don't think the 84 is it matters if you store something as X. Next year in calculus, when I give you the 89s, it will mess things up if you store things as your X. So I would just not be in the habit of storing something as the letter X, since that is the variable we use in y equals. I think they've changed like the newer calculators, the 84s, where if you do store something as X, it won't use that value for your y equals if you type it in, but I would not store this as X. If you do store it as a different letter than X. So that's the length of this side, 36.363. So now at this point, we can look at this right triangle right here. And since it is a right triangle, we can use regular trig, or if you have decided to cast away regular trig forever, then you could use law of sines again. But we've got our angle here is 56. We've got opposite and hypotenuse. So we would say sine of 56 equals h over 36.363. And it is. Why am I writing 36? Oh my. Do not know why I switched that to a 30. Might be losing it. Okay, so you would multiply by 46.363. So your H would be, we take that number right there, multiply it by sine of 56, and we will get 38.436. And this was measured in meters because we measured that side right there in meters. I feel like that's probably a little too tall, but I don't know, it's pretty tall. But we might need to go down there and try it sometime. All right, questions. All right, now your homework is just going to be plain triangles, but I like to go ahead and throw some application in here. We are going to do lots of application problems, but tonight it's just plain triangles for practice. I like to throw it in 11. We have got a triangle ABC. So A, B, C. Angle C is 80 degrees. Side B is 27. Side C is 15. And they want us to find measure of side A. So, for this particular case, this is really a solve the triangle problem, really. Because we've got to find angle B first. That's the only thing we can find in this triangle. And then we're going to have to find angle A. This is also an angle side, so we got to watch out for that ambiguous case, which we're actually not going to need. So if we set this up, we would have sine of B over 27 equals sine of C. Nope, don't put the C, put the 80. Over 15. And so we would cross multiply, we would get 15 sine B. Gosh, this is being so hateful today. Equals 27 sine 80. We would divide by the 15. So sine B would equal, we would need our calculator here, 27 sine 80 divided by 15 is 1.7726, and so on. Alright, so we got to do sine inverse here. It doesn't like me writing the word sine. I think it's the dot on the I that's getting me. Alright, so sine inverse of that answer does not work. Why does it not work? Sine, what does sine equal? I mean, I realize we're not dealing with the right triangle here, but sine does equal opposite over hypotenuse. So even though this is not a right triangle, the fact that that ratio sine is an opposite over hypotenuse. Which one's bigger, opposite or hypotenuse? Hypotenuse, always, right? Because that's what makes it the hypotenuse. So, if the number on top of the fraction is smaller than the number on the bottom, then this number right here can never be bigger than 1, right? Because you've got a smaller number on top and a bigger number on bottom. So sine of anything, even if we're not dealing with right triangles, it has to be less than or equal to 1. So if you see that you're getting sine of something is equal to a number bigger than 1, that triangle is not possible. So what that would mean, what that would tell you in real life, is that would tell you you took a measurement incorrectly. It's impossible that this exists this way. So it would mean one of your measurements is incorrect. So they threw a few of these in here because that's helpful to know, right? Because this would happen. Maybe that was really 40 degrees and you measured it as 80 degrees for whatever reason. So whenever you start doing your math to figure out what you need to know, you're going to get that this isn't even possible at all, which tells you need to go back and check your measurements there. So you will see a couple of these where they're not a triangle. So if this happens to you and you're getting that error whenever you do inverse sine, just write that it's not possible and move on. I don't love those because I don't like for it to be possible, but I like them so much more than having an ambiguous case solve the triangle problem. Because at least here you just stop and move on, right? It doesn't take forever. So we got about 12 minutes. Go ahead and work on those odds only. I think that'll give you plenty of practice for those. Of course, if you want extra practice, you can always do the evens there.